welcome to the Future of Transport webinar. My name is Nicci Rossouw. I am the CEO of Robotics Australia Group, and we are the peak body for robotics in Australia. I would like to begin today by acknowledging the traditional custodians of the land on which we meet today and pay my respects to the elders past and present. I extend that respect to Aboriginals and Torres Strait Islander peoples here today as well. Thanks very much to our expert panel for making themselves available. They've all got a hectic schedule, so I'm absolutely delighted to have you all here today. In the interest of transparency, I did invite a few women presenters as well who unfortunately could not make it today. So in the comment section, please don't hammer me for having no women here. They just unfortunately couldn't make it. I'd like to introduce you to Christian Ruberg. He's the Director of Robotics Australia Group. He will be hosting the panel and introducing our experts to you as well. So Christian, with that, I'll hand over to you.
Great, thanks very much there, Nicci. So just by way of a quick introduction, so the Robotics Australia Group, we're a peak industry group that supports the entire robotics ecosystem, from the builders of robots, the researchers, the system integrators, the educators, the robotics adopters, the business service providers that are essential, and also investors. So we're aiming to inform, connect, and advocate. And I think one area that I really think is important is just creating this innovation ecosystem so that we get broad collaboration, we can coordinate for efficiency, and it's all about creating opportunities and I think inspiring each of us. So I do invite everyone to engage and participate. I'll take this quick opportunity to thank our sponsors, Lang O'Rourke, Mets Ignited, RSM, Symbiotic, Advanced Navigation, and many others. And I'd refer you to our website to feature these great companies that are supporting us. So the Robotics Australia Group, our recent contributions have been the Robotics Roadmap. And so that was a 2018 submission, a very substantial document from our chair, Sue Key, and that's been recently updated in 2022. And it's a great summary and overview of the opportunities that our nascent industry have. Also, more recently, we contributed to the National Robotics Strategy, and again, this is a really important initiative. I think there was something like 50 submissions, so there's a lot of interest, and Robotics Australia are sort of key participants in that process. So this event is one of a series. It's focusing on different chapters of the robotics roadmap and addressing different industry sectors. And so we're wanting to explore the opportunities for our robot designers and all the enabling technologies, the sensing, the mobility, the intelligence, and the integration. And our solutions, they impact every sector of Australian industry and manufacturing, so really important. We have three great speakers. We've got about 15 minutes each and 5 minutes for questions. And so with that, I'd like to introduce Professor Marcus Foth from QUT. And Marcus, if you could quickly introduce yourself, and over to you. Thanks very much.
Thank you, Nicci, and thank you, Christian, for the kind introduction. I'm a professor of urban informatics, so my main area isn't robotics, but I do play a role in my research in the technology, computer science, smart cities kind of arena, and there's lots of crossovers when we are talking about mobility and transport and the future of transport. So the couple of slides that I wanted to show you are about not just the concept of smart mobility, but how, as those with expertise in robotics, as well as the wider field of technology, we have to very early on build bridges to those in policy, regulation, and governance, because otherwise there's the potential risk for the backlash. And so I'm going to show you a couple of these examples. Our work in the urban informatics research lab dates back to about 2006. We've been working in this intersection of the social sciences, the spatial sciences, and the computer sciences, if you'd like, so people, place, and technology. My original background has been in computer science, but I've done a PhD in urban studies and kind of embraced this hybridity of the digital and the physical and how they come together. And that's still quite a key approach in the way that we look at our research projects from this very holistic and interdisciplinary kind of point of view. If the person that is chatting there, Cassidy or someone, if you can put yourself on mute, or Nicci, if you can mute the participants, that would be great. We started this kind of work in our research quite early on, when the whole notion of ubiquitous computing kind of became commercially viable and became and received a lot of interest and traction. So you can see in this timeline that only actually goes to 2015 that we were quite early adopters, if you'd like, of this kind of research that combines the physical, social, and the digital kinds of aspects of ubiquitous computing. And our work is now embedded in the design lab that also brings us in touch with people, as I said, from robotics, but also from industrial design and other fields. I'm starting here to just set the scene with this quite soothing, I think, picture of the Shibuya crossing in Tokyo. So this is a spectacle that in essence happens every couple of minutes. And it's the kind of perfect efficiency of these autonomous agents called humans, not bumping into each other, some of them being on their mobile phones, being quite distracted, but still they usually make it very safely onto the other side. So as a kind of mobility and traffic scenario, this is kind of like the epitome of organized chaos that unfolds every couple of minutes. Now, what a lot of colleagues are aspiring towards is to try and replicate this optimization and efficiency in the new world of autonomous vehicles, for instance. This is some of the work of my colleagues at the Sensible City Lab at MIT, where they have been trying to envisage what would an intersection look like if we now are dealing with autonomous vehicles. Is it, for instance, possible to imagine a traffic world that can do without traffic lights? Because in this particular case, we might be able to slot them in through a demand management system that provides just-in-time maneuverability through these types of intersections. What this though does is it focuses our attention and our technical expertise on a particular area. And in the transport space, there's a lot of them in that space of efficiency. I just want to draw your attention on the left side, which is about the car utilization. This is data from the Ellen MacArthur Foundation. It shows here that the typical European car is parked 92% of the time. 1% sitting in congestion, 1.6% is looking for a car park, 5% is the actual driving task. Now, this is quite stark in terms of the figures, but now imagine that for the first time, we can actually bring down the average occupancy from 1.3 or 1.4, depending on which jurisdiction you're looking at, to something that is below 1. Because now we can actually have the scenario that robots are driving these cars, which means that they can drive autonomously. You might have seen these kinds of illustrations are used to illustrate the investment in active transport infrastructure as well as public transport. And it says there, for 69 people to be accommodated in one bus, this is the space that they would need if they were to use bicycles or if they were to use cars. But the actual kind of distinction now is that we are operating towards a world where we are looking at electric cars or even hydrogen-powered cars, but the ramifications for public investment in the infrastructure needed might even propel and is going to be made worse, if not better. And this is all based on something that my colleague Graham Curry at Monash, who's now the director of Monash Infrastructure, has been going on about for a very long time. He says here in his article in the Herald Sun that transport lies are keeping us in a world of congestion. And this is largely because of the fallacy in not wanting to believe in the realities of what's called induced demand, which means that if there is congestion on the road, a lot of the lobby groups like here in Queensland, the RACQ would ask you for more roads to be built. But once those roads are built, they will very quickly fill up with more traffic. So what is needed in order to go about this in a different way? Well, we've been looking at public transport. We've also been looking at ride sharing. And Uber was originally are you guys still there? At the moment, I'm seeing some advertisement. Is that kind of part?
No, I can see you, Marcus, but I've just got a black screen at the moment.
So I'm just seeing some advertisement now from Trello. I'm not sure why that's happened. Let me just try and share this again.
Oh, there we go. I can see you again.
Oh, that's bizarre. Okay, try this. Okay, is this kind of coming back up again?
Yeah, no, we're back again. Yep, thanks.
Okay, so originally when Uber started to disrupt the transport mobility space, they were kind of heralded as the ones that would bring disruption to the taxi industry. But that's really changed quite a bit, because the research indicates that with the particular commercial models that they've employing, and also their investment in R&D to lead towards autonomous vehicles, what they are actually going to do is kill off public transport. So some of the cities that have this feature of the pool pricing, you actually are now seeing that they are competing with public transport, and that should be of concern to all of us, because it can jeopardize everyone's taxpayers' investment in public transport infrastructure if all of a sudden people are not using trams, buses, and trains anymore, but they are jumping into the next Uber, which then perversely contributes to further congestion. So services like Uber Pool are said here in the Washington Post are making traffic worse. And that is not necessarily a feature or factor of the technical advancements. It's actually a factor of those in the technical and R&D space not thinking soon enough about the policy and regulatory implications. This will soon be a reality for advanced air mobility. This is one of the themes that was featured on A Current Affair recently, where the Logan test site for drone delivery services is causing a lot of upset residents because of the lack of engagement with those stakeholders. And so the regulatory environment is something that I think we all need to be paying attention to, rather than leaving it up to governments to try and figure this out in retrospect in order to try and catch up. It's so essential for us as a sector to obtain a social license to operate. So this is really a big point around the technological solutionism, and I just want to finish off by talking about some of the things that we are doing in response, which is to try and juxtapose some of these industry design briefs that are all about speed and agility and efficiency with some more experimental thoughts about the complete opposite. In this case, for instance, this notion of slow cities, which is adopted from the Italian original movement around slow food. So what this kind of looks like, for instance, is actually trying to remind people that cities are not necessarily just about getting very quickly from A to B. It can actually make sense to be much more exploratory and slow things down. It can actually be really positive for adjacent outlets. And so this one here is an example that's called My Parking Day, where one day a year, a particular section of street across the world, this is an example from Salzburg in Austria, is in essence reoccupied by the local neighborhood and turned into a park. Not a car park, but an actual park, as you can see there on the right side, with deck chairs and lounge chairs and music and performances. Similar things in this space of tactical urbanism are yarn bombing, where public infrastructure pieces are repurposed and reappropriated temporarily for other kinds of initiatives. And a famous example we have here in Brisbane and other Australian cities as well, originated in France, which is the Dîner en Blanc, the dinner in white. This is the quite a famous intersection near the University of Munich that they've been occupying for an alfresco style dining experience. So I'm showing you these photos because when we are talking about robotics in the role of bringing about the future of transport and mobility, we also need to sometimes question the kinds of criteria and parameters that we're operating towards. Do we really want to speed up everything? Is there perhaps other design goals and experience objectives that we want to aspire towards? If you want to read a bit more, there is a op-ed that I've written for the conversation with the same title. It's called Smart Mobility Alone is no substitute for strong policy leadership. And we're also exploring some of these themes in a new industrial transformation training center that was awarded earlier this month, where we're working with a number of universities and industry partners on bringing automated vehicles to regional and rural and remote parts of Australia. So this is led by QUT. You can see some of the colleagues there at QUT and maybe some of the familiar faces, but it does have quite a prominent footprint in that space of community engagement and social license, as well as trying to do research in the space of smart policy and regulation. Thank you.
Fantastic, Marcus. That was a great presentation. I think really widening the conversation as to really where transport could go. I think that was fantastic. I'm just looking at the chat to see if we have any questions, but I think if not, I'm just going to lead off with a first question, and that is that I guess the key drivers of change may be congestion, decarbonisation, and new low costs kind of technologies. I guess our audience are robotic service providers and technology service providers. In your opinion, do you think our technology sector is ready for these opportunities? And what kind of collaboration is required to kind of take advantage of these trends that are happening in transport?
Look, I think there is a lot of demand on the consumer level to do the right thing. Consumers these days are far more educated and far more savvy. At the same time, though, overall, the industry is prone to a lot of greenwashing, especially the aviation industry, but it does extend to other parts of the transport sector more widely. So when we, for instance, talk about electric vehicles, it actually does depend on the source of the electricity. Similarly with hydrogen, hydrogen is heralded as this kind of panacea that will solve all our problems, but there is, anything from black to brown to blue to green hydrogen, and we obviously are trying to optimize the use of green hydrogen rather than the one that is generated with fossil fuel sources. So I think there is definitely an opportunity to meet the demand of consumers that want to do the right thing, and it will also be, I think, a competitive advantage to be genuinely sustainable rather than to engage in greenwashing. You might have seen in the news that the ACCC has been going after Qatar Airways for using misleading slogans in their marketing at various TV ads and even sports stadiums. I think that will probably be something that we'll see more often, but it's actually, a very interesting technical challenge. One of my colleagues, for instance, are working on blockchain research in order to credential the origin of certain energy sources to give consumers the confidence that what's on the label is actually also what's under the bonnet.
Yeah, and I think there's it's a little bit of a complicated and challenging space, but nevertheless, I think there's enormous opportunities, and I think it's a bit of industry collaboration to kind of decide where we can develop technology and compete globally. Thanks very much there, Marcus. Next, moving right along, I'd like to introduce Rob Sutton of Mirragin. Rob, if you could briefly introduce yourself, and the floor is yours. Thank you very much.
Hey everyone, my name's Rob Sutton. I'm the Managing Director of Mirragin RAS Consulting. The RAS stands for Robotics and Autonomous Systems. We're a drone consultancy, and our mandate is we help other organisations implement their own drone programs. And we do this for three reasons. One is to reduce costs. The second two is allow people to do things that they couldn't do before, allow them to do more. And the third, which is probably the most important to us, is we help keep people safe. So we use drones to take people out of those dangerous situations where a machine can do the job equally well. What I'm going to talk about today is a concept called advanced air mobility, and so I'll just share my slides on that now. So I guess the first question then is, what is advanced air mobility. Generally, it involves a small number of passengers, so somewhere between 3 to 5 people. It involves a platform which is short or vertical takeoff and landing. So what that means is that it doesn't require a runway, and generally it will operate off a small platform like a heliport. In the context of advanced air mobility, the language that they use is called vertiports. Typically powered electrically or by renewable fuels, so they're not powered by fossil fuels. And there's 2 different categories of advanced air mobility. There's urban air mobility, which is movement around a city, and then there's regional air mobility, which is movement between cities. So what are the benefits of advanced air mobility? So quite simply, faster, cheaper, quieter, greener. So faster, what does that mean? To think of a situation where advanced air mobility might be useful, imagine that you were in the middle of New York, you wanted to get out to the airport. If you were going to take an Uber or a taxi or drive, it could take quite a long time. It could take an hour, it could take an hour and a half, it could take 2 hours, depending on the traffic. If you were able to go to a location in the city centre, hop in an urban air taxi and go straight out to the airport, you're getting there in a matter of minutes. So it can be substantially faster than other modes of transport, particularly when you're talking within a city and dealing with some of those congestion issues that were spoken about before. It's cheaper, and cheaper is relative. So it's more expensive than some forms of transport. It's less expensive than other forms of transport. Where you're comparing it against something like a helicopter, it should be cheaper than a helicopter. Where you're comparing it against something like an Uber, if you are hopping in an Uber and you are driving, in my context, between Brisbane and the Gold Coast, that is quite expensive, and it's likely that it would be cheaper to take an advanced air mobility platform between those 2 locations. Quieter, in this case, quieter than helicopters. The rotors that are used on these platforms are quite low noise. There are still some noise challenges, and that comment before about Wing and Logan having to have a social mandate to operate is still very relevant. One of the things that's keeping helicopters out of city centres at the moment is that they are too noisy, and having a platform like this can make a big difference. And then the final one is it's greener. So a key selling point, if you like, of this technology is it's zero emissions. So they're typically battery powered or renewable powered. So comparing to a fossil fuel powered car or a fossil fuel powered helicopter, it's definitely a greener option. So what are the current challenges? The first one there is around safety and manufacturing standards. So that's talking about these things carry people and therefore need to be manufactured to the same standard that any other passenger carrying aircraft needs to be manufactured to. So you may see a lot of videos about drones being used to carry people. I saw an example the other day of a lady holding onto a drone, and the drone lifted up, flew her out over a swimming pool, and she dropped into the swimming pool. So that's all fun, except for the fact that the safety standards are not up to speed on drones compared to commercial aircraft. And if you're going to have passengers, then they need to be at the same level of safety. So just making sure that people who are manufacturing these kind of aircraft are manufacturing them to the same level of safety, that are doing the appropriate tests and the appropriate certification. And the massive difference between a drone that can work and a drone that can work safely is the certification costs. The second is integration with other aircraft and with ground transport. So this is just acknowledging that urban air mobility or advanced air mobility is one form of transport in areas that have multiple forms of transport. And what matters is not necessarily the ability to get from point A to point B. It's how those trips work for an individual that is traveling from location X to location Y. So, for example, when I came in the city of Brisbane today, I drove to the train station. I walked from the car park to the train station. I caught the train into the city, and then I walked from the city to my office location. And it's the same kind of consideration as these are just one leg of a multi-leg transport. And so the intersection of those different modes becomes quite important. How do you move from advanced air mobility when you walk to the vertiport in the city, you catch the advanced air mobility platform out to the airport, and then you've got to move from the airport to the passenger plane that you're trying to get to? How does that flow work? So that's an important consideration, and that flow is something that isn't really in place for these platforms at the moment. The fourth one there is demand modeling and vertiport locations. So if these things are to be useful, then they need to be accessible, and there needs to be locations where you can access them from. So where do you put the locations for these advanced air mobility platforms? If they go in the city, where are they going? Are they going near ferry terminals? Are they going near bus terminals? Are they going on top of buildings? Where's the infrastructure for that? Where's the planning for that? Where's the modelling that says, here are the kind of routes that people want to use and where it makes sense economically, and then where do we need to place the vertiports to support that? So that is a big outstanding question for the industry at the moment. The fifth point there is around sustainability of advanced air mobility whole of product. So if it's a selling point that these things are greener, then they have to actually be greener. And Marcus raised the point before about greenwashing. The whole of life cycle, the whole of product, the whole of system has to be considered with these platforms, because is it true that they are greener if you compare them against things like hydrogen-powered car, for example, or green hydrogen-powered? So that's also something that the industry needs to grapple with a little bit. And then decarbonisation. So obviously it's not just about where the power comes from, as in these are battery powered, but where does the power come to power them in the first place? And how do you remove those emissions from that whole system? So those are the primary challenges that are preventing a wider rollout of advanced air mobility at the moment. Some interesting companies to watch. So the first is Wisk, and that's the yellow plane in the lower left corner. Wisk are an American company. They do have a presence in Brisbane, in Australia. And they, for example, they had a demonstration in King George Square a little while ago. One of the key differences between Wisk and a lot of the other platforms is they're looking to make a platform that's autonomous. So advanced air mobility includes platforms that are crewed by a pilot, and also systems that don't have a pilot in them at all. And what Wisk want to do is to have an uncrewed platform, which means that you get into the platform and there is no pilot sitting in the platform with you. There are other companies like JB Aviation, also a US-based company, a company called Eve Mobility, and they've come out of Embraer. Then Airbus, and Airbus have an interesting concept with theirs in terms of they're moving around a pod, and the pod itself is what you sit in. The pod allows that intermodal transport because it can connect with public transport, or it can move on its own right, and it just interfaces with the air mobility equipment. And then Volocopter, which is the bottom right, and they've got different platforms for urban air mobility, so movement within cities, or regional air mobility. And the one in the picture is their Volo City platform. And they're, like I said, they're based out of Germany. So those are the biggest and most well-funded companies. Those are the companies that have the resources to actually certify their platforms. And I would say that when we see air mobility rolling out in our cities and across our regions, it's likely to be these companies that are leading the charge. And then just to close with a picture of the Brisbane Olympics, why do I put this up? Because there is an ambition to have advanced air mobility in place in Brisbane for the Olympics in 2032. This stuff is not here now, but it is coming very soon, and there are quite ambitious plans for this to happen, and very advanced plans to have this at the Olympics, if not before. So that's my presentation. Happy to take any questions.
Fantastic there, Rob. I'm just blown away with these systems that are coming at us. It's not often in in generations that you see revolutionary products coming, like the car, like the mobile, like our mobile phones, and now this kind of whole mobility thing. And looking at the graphics and the technology, it's all coming together. It's like I'm just like wow. I guess a question is, these kind of fully autonomous and driverless platforms, they've been foreshadowed for a few years. They're complex. There's some expense there. You think it's realistic that we'll see these in what sort of time frame? And a second part is Australia can develop technologies. I think it would be difficult to build the whole machine, the whole system, but I can see all sorts of driver assist or other sort of technologies that spin out from this initiative. What are your thoughts?
The two questions there. I guess in terms of whether Australia or where's Australia's role in all of this, and I think this is it's a little bit like a question around building large scale passenger aircraft. It is an expensive game. It does require deep pockets. It is not impossible that a vendor in Australia comes up with an advanced air mobility product. I would say it would have to be very well funded and have to be very globally connected in order to be successful. We do have the technology here. We have the people that could make this happen here. It would just be a case of somebody driving it and being able to make the investment case and having substantial resources sitting behind it. It's not by accident that Eve Mobility has come out of Embraer. It's not by accident that that Boeing has a very strong relationship with Whisk. There are clear connections to the very big aircraft manufacturers because this stuff takes a large amount of resources. Just by way of comparison, Whisk has something in the order of 700 engineers on their books in order to certify the platform. So that is an enormous expense by anyone's measure. The things that are limiting the rollout, those issues that I spoke about before, is around things like vertiports and who pays for them. How does that work in terms of planning? How does that tie in with kind of state and federal and local governments? Where's the business case? Where's the economic case? Where's the driver? Where's the community acceptance and community engagement around these platforms? And I'd say those are the bigger ones that are getting in the way. And in terms of where would there be opportunities for Australian companies, it would probably in those kind of spaces, particularly around things like vertical construction and vertical design. And there's a very interesting company in Melbourne called Skyports that is actively looking to pursue the construction of those. I think that's your second question, and I've now forgotten your first question.
Oh, the first one was just just the time frame when we'll realistically see this rollout and the scaling, I suppose.
Yeah, so I think it's reasonable to expect to see crewed platforms within the next 2 years.
Wow.
They are almost all of those companies are at the very later stages of testing and certification, and you'll see pilots and trials being rolled out kind of across the globe. In Australia, the companies that are involved in Australia are pushing for somewhere in the order of the 2026 timeframe. So that's still 3 years away, but that's actually pretty close when you consider the planning process for getting some of these vertiports approved, for example. So really that should have started a year ago in order to be kind of in place for 2026. The autonomy one is a different question because in order for these platforms to be safe, the target level of safety in commercial aviation is one, I might get this wrong, one failure, one fatality in every 1 million flight hours, which is still, given the number of flight hours that are accrued globally, that's still quite a large number of fatalities. And I think typically when aircraft are designed, they're designed for 3 orders of magnitude more than that, so 1 in a billion. Now, to get to that level of safety with an autonomous system is going to be interesting, because with autonomy and with artificial intelligence, we can get it to work, but can we get it to work regularly and repeatably so that we know that in 1 billion flight hours, we're not going to have an instance of the command software saying, I feel like flying into a building today because of some trick of the light or something that it wasn't trained for, and it just assumes that that's, a place where it can fly. How do we know for certain, or at least how do we know that we're going to be better than the commercial aviation? And that is still a very difficult challenge. And that applies across the board from an artificial intelligence perspective or machine learning perspective.
Yeah, really interesting there, Rob. So partly the opportunities around kind of infrastructure, but I guess there's a huge technology stack, and I would have thought, you break up an aircraft into all the different technologies, and there are opportunities with each one in terms of performance and reliability, and I think breaking the problem down into all those different opportunities, I think is could be interesting. Thanks very much there, Rob. That was fantastic. Now I'd like to introduce Ashley Jensen from Smart Industrial. Ashley, if you could introduce yourself, and you've got the floor. Thanks very much.
Yeah, thank you, Christian, and thank you, Nicci. I'll just see if I can get the slideshow up now. Is that working?
Yep, that's it. Great, thank you.
So just a quick introduction of myself and Smart Industrial. So I'm the founder and CEO of Global Operations for Smart Industrial. So we're an Australian-based company based in Brisbane, and we're a vertically integrated solutions provider. So what does that mean? We do all of the, the research, the design, the development, the manufacture, the support then of both from a mechanical to an electronic to a software for integrated solutions. Our focus has been in heavy logistics in Australia, and a couple of industries in particular, and concentrating on bulk liquid. And a couple of those industries, or one of those industries that I'll go through today, is something that I guess everyone would know about, is actually the dairy industry. So it's going to be a little bit of a different focus to what Marcus and Rob have been, but it's more around the actual logistics of product. Just a few fun facts around the dairy industry. Some people may not be aware of, and our focus is on for the dairy industry is the raw milk supply from when it's been milked to when it's been delivered to the factory. So raw milk deliveries in Australia is about 8.7 billion litres per annum. That equates to 115 million kilometres travelled to collect that milk and deliver it to the factory. That doesn't include factory-to-factory transfers and deliveries then to supermarket from there. We're just talking about the actual raw milk. Now that equates to about 320,000 trips. From an efficiency point of view, the industry average is, so we're talking about generally in Australia, it's truck or prime mover and tanker and combinations of tankers. Usually now it's multiple combinations. And when we talk about an efficiency there, what we're talking about is the amount that the tankers can carry compared to what they're actually putting on them. So the industry average is about 83% filled. Now, one of the challenges with logistics, and this is not just in milk, but is where most industries have, supply and demand changes. So in the dairy industry in particular, that supply is coming, and in a lot of cases in Australia, that is weather dependent. So that supply curve can change. Different geographical regions then have completely different profiles of that supply. So that creates, I guess, a number of challenges that it's, I guess, and similar to, a lot of other industries, but I guess in a different way. So to give I guess an overview of what that operationally means, the capital cost of a truck and a tanker combination is in some cases just under $1 million. Now, breakdown of the ownership, I guess the operating costs of that equipment, and this will make a little bit of relevance later on when I'm. But the ownership cost of that equipment is approximately 30% of the total cost. The labour cost is about 35%. The fuel cost is approximately 28%, and the maintenance and other bits and pieces make up the remainder. Now, I guess the important point to note here is particularly related to the labour cost. The labour cost is the largest cost in the operation, even though the units themselves are in some cases close to $1 million. Now the trends over the last 20 to 30 years in the industry, and this is in Australia, has the tanker size has gone from 25,000 litres capacity on average to, in the last couple of years, about 34,000 litres. Now, I guess an important thing to note there is that now that we're working in other countries, and particularly in the US, one of the things that we do see here in Australia is the innovation that has happened in Australia compared to some of those other countries. And the industry in Australia, or say compared to the US is about 20 to 25 times the size of the industry in Australia. Their average tanker size is still about 25 to 26,000 litres. Now, there's a number of factors to that, but one of the things that Australians are fairly good at is innovation, and the innovation that has happened in Australia, and there's been regulation that's allowed that, which is an important point as well. But the innovation that has allowed those tanker units to become bigger has and in a lot of cases, even safer than the smaller equipment, has actually come. It's been developed here. From an operations point of view on the truck units themselves, go back in history, very little of the automated transmissions, whereas you look at the industry now, and it's greater than 70% of all that equipment is automated. The other big change then is around the informatics and the driver assist systems. So, previously it was just a truck, had to be a very specialized person to be able to drive that. Whereas now it's, that equipment is more like a car. But there is there's a huge number of added on equipment now, from driver navigation to start with, but then also driver fatigue monitoring, sensing around the equipment itself. I guess, and comes back to then the fourth point then is around the driver experience. So you would go back in time, for that type of operation, which is a fairly complicated operation, they were experienced drivers. Whereas now, it's generally fairly inexperienced drivers. It drops back to sort of that 5 to 10 years. So in a way, that's been one of the drivers for that. So when we look at we peer into the future of logistics, and I guess some of this has been based on our experience breaking into new markets and getting product that changes the industry. I guess one of the key, and I've done these in order, and they are generally the order that the industry, or to actually get a product to market and to get market acceptance, are what we've found to be in that order. So number one is the economics, and I know it's been mentioned a couple of times now about greenwashing and those sort of things. So although we hear so much about the environmental aspects and reduction of ESG and all of those things, they are fine. But unless there's a product or a technology actually makes it, or the operation, cheaper, then it doesn't matter how much of that stuff you've got. It comes after the economics. So I guess in the heavy transport industry, safety then comes next. If there's it's becoming more and more that there is not and call it a social license, or there's not a license to operate without good safety records, and that really comes those key drivers come from insurance. So if companies are not operating best practice, then either their insurance premiums will be so high, or they won't even get insurance at all. So again, the safety, in a way, comes back to the first point of the economics of the operation. Number three, the labour shortage. Now, this is an interesting one because this has become, since COVID, or during COVID and since COVID, has probably become much more of an issue. Now, I guess the interesting thing that we thought here in Australia, based on the migration workforce of the overseas workers and those sort of things, being during COVID, that was why there was a labour shortage. But in the other areas in the world that we operate, they are in the same boat. So it's something that's not just here in Australia. It's a global issue, and that's where we see the technology of not necessarily even automation or fully autonomous vehicles or those sort of things, but technologies that are enabling technologies to go from something where you've got to be a highly experienced person to do the operation, to being someone that can be shown it once, and the technology leads them through it, just making them do the certain bits that the technology can't do, or where it's got to be, there's got to be decision points in it. The last point being the environmental factors. That may change over the next few years, but at the moment, that probably comes after all of those other items. And where does that come from? I guess it's when you look at say the operations of heavy transport logistics, to moving our food product and our energy around, generally that's the the energy cost to do that is about 30% of that operation. So, you know, if the economics of the technology then make it cheaper to operate or more efficient, and it also then potentially reduces, the energy usage or the, less carbon, whatever it is from an environmental point of view, then that's going to be, where market acceptance can happen. So in my view, so areas that the gains will be most likely is automated processes. So the fully autonomous operations, particularly in heavy transport operations, are a long way away, in my opinion. However, there is a lot of processes that go into those operations that are where we see the opportunity, and it's automating those processes, whether that's from a software point of view or whether it's from an integrated hardware and software. Dynamic scheduling. So being able to have systems that capture real-time information, but with context that can be fed into other systems to schedule that. To give an example, that industry average of 83% efficiency. So the operations that are using our suite of software and hardware, they're operating about 95%. So an industry where their profit margins are between 6 and 7%, you can go from 6 or 7% to a 15 to 20% profit margin, or they can have that price advantage in the market. There's a lot of, I guess, the part there that comes into is, I guess, the AI powered. We're moving from industries where people have been in that industry for 20 or 30 years and they know, everything there is to know about all of the intricate details to be able to make that efficient. Where we start to bring data from different areas. An example of that is one of our systems where we have sensing systems on farm that not only sense what production is happening, what storage is happening, but also looks at the weather. So we have on-farm weather stations that we then apply modelling to that to then predict out over the next few days then what that production is going to be, that then feed into those scheduling systems then for scheduling those trucks to be there, but also scheduling the maintenance of that equipment. Number 3 is standardised freight task. So there's a number of in heavy transport. There's a number of different areas. The standardised freight tasks are those type of transport operations where you have standardised packaging that can be automated, or it's from warehouse to warehouse. So it's known routes, it's known locations. Those sort of operations which can be overcome regulation in a way because they can be controlled, or it can be automated on both ends. One of the big issues with heavy transport is that you are moving a product from one location to another, and in a lot of cases you need resources on both ends to either load or unload. So from a standardized freight task, there's where, and you see this a little bit in the US, where there's been some trials around automated warehouse to warehouse trucking and those sort of things. The other one is automation for machine to machine interoperability. So one of the I guess the big issues that a lot of our customers will raise with this is that they have this equipment, but then they've got to have 5 or 6 different vendors for all these pieces of equipment because they don't talk to each other. So, and then obviously when they don't talk to each other, then they can't get context from each other around what's actually going on. So that's one of the areas that we see as a fairly large opportunity. And then alternate, cleaner fuel sources. And probably in our view, they're particularly electric. And I guess the issue's been raised around the greenwashing and those sort of things by previous presenters. And I guess this comes in our view. This also comes back to that number one point previously around the economics of it. Until the economics of those alternate sources, whether and hopefully cleaner sources, when the economics of those stack up to what the current economics of running diesel engines, for example, that's when it will get adoption. And one of the things that particularly electric does, I know in one of the previous presentations of Marcus was around the cars and how little time they are actually driving. In some transport operations, that's similar, where it's they're only driving for certain periods of time. And for some other operations, then on the equipment, they need to run the engine for a power source. For example, most prime movers now are between a 500 or 700 horsepower engine. If they're on site picking up, they'll be running that engine to run some other ancillary equipment that might only be pulling 20 horsepower. But you then end up with this massive fuel burn just for that small operation. Whereas once you look at particularly electric and battery and those sort of operations where that gives that flexibility, there's opportunities to be had there. So barriers to full autonomy. So if we had to look at what the future of logistics is, and we talk about transporting people, we talk about transporting goods. What do we see as the barriers to getting to that full autonomy? In our view, that highest barrier, or the first barrier, is regulation. The technology is there. It's been there. My background is in mining and agriculture. It's been there for 30 years. Full autonomy on farms in mining spaces is well and truly advanced. It does what it needs to. So the barrier for getting that while it's interacting with, and particularly interacting with humans and the risk that associated, that comes down to regulation. I was reading an article the other day where California has now put in regulation that you can be running autonomous semi-trailer operations, but you must, for the next 6 years, they've mandated you must have an operator in that equipment. So you go back to the original slide where it's the labour cost is the highest part of that operation, which is 35% of that operation. And then a regulation comes along and says, you must have that. Your autonomous vehicle will be more expensive, but you still also need to have that labour associated with that, and it's got to be there for the next 6 years. That one piece of regulation pretty much kills that autonomy in that jurisdiction for the next 6 years. And similar here, that in a way, there is some regulation, but that's kind of a moving feast.
Tell you what, actually, we're hitting a bit of a time barrier.
Right.
So if you could conclude, that would be great. Concluding comments.
Yeah, so that's pretty much it. So yeah, the technology capability, obviously that's where we see the opportunities as well as the barriers. And for Australia, the network connectivity from a full autonomy. Yeah, so that's it from mine.
Fantastic there, Ashley. Tell you what, I really enjoyed that. I think you've taken us from the kind of the high level trends. We've kind of gone through the navigating the hype curve, and now you're right into the practical solutions. And I think what your presentation says to me is how important domain knowledge is. So for technology providers, it's really understanding the needs, and that can take a long time and a lot of commitment. I'll just try for one quick question, because we really have run out of time. I guess exporting and developing these solutions and getting and exporting these solutions. Just in a few words, what are the barriers that stop Australia developing solutions and exporting them?
Yeah, good question. And one of the big issues is our cost of manufacture, our cost of development, our cost of manufacture, and our small base of unit numbers to be able to produce for, to then be able to be on a scale to get export markets. Yeah, that's probably the main thing. And from I guess an Australian based is access to capital markets to do that.
Yeah. So yep. No. It's once again, it's one of those kind of systemic challenges that we've got. And great presentation. Thanks very much. Look, at this point, I'd just like to thank our three speakers. Everybody is busy, but the Robotics Australia Group really appreciates. There were three fantastic presentations, and I'd like to pass back to Nicci if you'd like to wrap us up.
Thank you, Christian, and thanks to our presenters again. Thank you for your time, much appreciated. To our audience, if you haven't connected with them on LinkedIn, do so immediately, please. And if you've got any further questions, that would be a great place to continue the conversation. We will have a next webinar on the 27th of September. Please follow us on our website, subscribe to our newsletter, and also follow us on LinkedIn for regular updates on what we're doing as a group. And I hope you have a wonderful rest of your day. Thank you so much for joining us.
Thanks, everyone. Thanks, Nicci.
Thank you.